Hello, everybody. I think we are live, and as soon as that happened, my VS Code started freaking out. Let me see if I can do something about that. Ooh, it's bad. Again with that, guys. Sorry. Can everybody hear me okay? I think I've got the live chat pulled up on YouTube. So if you drop your questions in there, I will be able to get back to them as time permits, if we've got some time at the end. Let's see if this is working yet. Oh, sweet. Awesome. Sorry about that, everybody. My name is Elliot. I am a developer advocate, jack of all trades here at the Stellar Development Foundation, and I am so excited to be here with you today. And I'm excited for what I've got to share because it has the power to get people on chain and onboarded to the network like never before. It is truly a game changer. We are talking about passkeys today, but before we get into the specifics and how we build with them, why are we talking about passkeys? So if you're watching this as a developer, you've probably had a similar experience to this. You want to interact with a blockchain, you want to get on the network, and the very first step, almost universally, whether you're talking about Bitcoin, Ethereum, Stellar, whatever the case may be, you're going to have to choose and set up a wallet. And that's true if you're building something. It's also true if you're just trying to use the network as an individual, as a user. And that experience is often less than frictionless, right? And much of the time it's downright bad. And for the technically inclined among us, that hurdle is one that we are willing to jump over. But for the run-of-the-mill user, the everyday person that we want to see on chain using our apps, our products, that hurdle is often too high for them to actually want to attempt. And that friction represents a really serious barrier to entry for potential users. But more than that, it's also a serious barrier if blockchain as a whole wants to gain adoption. And we need to make getting on and using the network as frictionless for users as it is for them to sign up for and use TikTok or whatever the latest thing is these days. And this is exactly where passkeys come in. There's no more third-party wallets to integrate. There's no more secret keys. There's no more seed phrases that you got to back up or copy and all that hassle. It is just intuitive and it just works. As an experiment the other day, I had my 12-year-old daughter and my wife, both admittedly non-tech savvy people, try this out, and they were both able to sign and get transactions on chain without even realizing they were using the network, just by using their thumbprint or their Face ID, whatever the case may be. I'm telling you, Passkeys has the power to make everything different. So what is a passkey? It's part of the WebAuthn specification. Users can use it to securely authenticate with a public-private key pair, and that key pair is encrypted and managed on their device. Often that's paired with some kind of cloud service like 1Password, iCloud, Chrome Sync, that kind of thing. And in practice, this allows a user to sign up and authenticate with web apps without having to use their password at all, just by cryptographically, yeah, that's the word, proving that they have the credentials. The big companies, the likes of Google, Mozilla, Microsoft, and a lot more, have done the hard work to get this powerful, robust, and secure everyday encryption into the hands of the general public. And the amazing thing is, we are now able to build on top of that work to authenticate on-chain transactions using those passkeys. So how do we do that? Well, Stellar, as of Protocol 21, supports the SEC-P256R1 encryption curve natively on-chain. And that means you can utilize those passkeys a user has created on their phone, their laptop, their YubiKey, whatever the case may be, to sign transactions before submitting them to the network. And today we're diving in how we can implement that in a really simple dApp. And we're going to use a tool that Tyler, another developer advocate here at SDF, has developed. It's called Passkey Kit, and it seriously puts your implementation of passkeys on the fast track and makes it quick and easy to start. And it gets you developing with passkeys in mind from the very beginning. This Passkey kit, along with LaunchTube, a service that SDF is currently experimenting with, abstracts away so much of the headache and hassle that you typically have to go through to get users logged in and signed up with a blockchain wallet. So let's dive in and build this thing. What we're building is a dApp that's going to allow a user to sign up, and it will create for them a passkey powered smart wallet. And then they can use that smart wallet to interact with our smart contract. And this dApp is a throwback to the internet guest books from back in the day. If you've been around long enough to remember those, I know I sure do. So let's jump right in. First, we're going to clone the boilerplate repository, and I've got a particular branch I'm going to use to demonstrate this. And we're going to get into the guest book, and let's npm install so that it starts going. And while it's doing that, we can take a brief look at the source code. So this is the smart contract. We've got a contracts directory, and you could store more than one smart contract in here. I just have the one at the moment. And it's got a few different functions: initialize, write message, read message, a couple others, read latest, that kind of thing. These two, read and write message, initial, wherever it went, write message, there it is. These are sort of the bread and butter of what the smart contract is. And we actually use this smart contract to initialize our dApp. So we have this script that will run in a second, and it's going to use, it's going to build, deploy, and initialize this contract. And then it's going to generate these TypeScript bindings that get stored in this packages directory. And for each contract you generate a bindings for, it will give you like all of the stuff that you might need. It generates from the network the contract address, the error messages, the input and output types. All of that stuff is defined and generated directly from the chain. These bindings are a pretty sweet deal if you're developing a contract and a front end at the same time. So we are now in our guest book, and we need to have some environment variables set up. So here's the example one, and most of these are just pretty typical, pretty standard. The native lumens contract address, this factory contract is the deployer of all these smart wallets. And you can change this to get a different smart wallet experience for your users. We're also going to be using Mercury, a data indexing service that runs on Stellar, built by a wonderful, intelligent, like super brainy community member. It's amazing. And then we've got some private ones that I'm not going to show you mine, but I'm going to copy from my home directory into the .env file. And so we can finally get to, we have initialize, and what do we not have here? Let's save our passkey kit as well. So we will run, hold on, let's get our TypeScript server working again. I don't know what it's doing, but we're going to run npm run init to actually deploy the smart contract, initialize it, generate the bindings, that kind of thing. I don't know why it's type checking this initialize script. Oh, well, I think it'll work. Can't wait to find out. It's been doing this to me. It's been erroring that the guest book account that it's creating isn't working, but every time it's done it to me, I run it again and it works. So I don't know what's going on. Something wrong with my script, probably. And it initializes it with a sort of welcome message so that the admin can be defined in the contract. And then also there's sort of a greeting for people who are going to use the book, the guest book. All right, so we can open up a new shell and we will use that to start a development server. Whoa, get into guest book. Okay, so if we refresh the page here, it should, in a second, there we go. Okay, so this is the app we're building. So it's got a sign up button, a login button. Those don't do anything right now. I'm gonna pull up the console. They are just sort of function placeholders. A lot of this is just sort of placeholder stuff at the moment. But we've got a view wallet button, send donation button if you want to donate to the cause, log out, again, doesn't do anything. So those are the things that we're going to actually implement today. So first, let's go into get all this minimized, into the source directory. This is a SvelteKit app. Take that for whatever you need. It works really well with the TypeScript bindings. I've got a sort of contracts import export utility here. But the first thing that we need to do is get our Passkey client kind of up and running. And this is as simple as it is. So we're going to import from our Passkey kit. The SAC client is just a token client. We're going to import Passkey kit as well. And we're going to declare account equals new Passkey kit. And it needs a bunch of a bunch of things that are set as environment variables. So we'll do the RPC URL. Factory is going to be the public factory contract address. And we need the network passphrase. And that's also going to be one of the environment variables. And that's literally it. You have a couple of imports here of the environment variables, the strings that these are. You could just define them here just as easy. And this account object we'll use over and over and over again to actually call and build these transactions that we can then sign. Okay, so the Passkey client is done. This is what the user will use to interact with our contract and interact with their passkey. And what we also need to do is implement a Passkey server. So this is going to be also from Passkey kit, but we're going to import Passkey server. We're going to export it like this. Export const server equals new Passkey server. And it needs also the RPC URL. Where is that? There. It needs the launch tube URL, which I have as a public variable as well. Launch tube is the service that we're developing at the moment still, and it allows you to not even have to worry about getting a funded account to submit transactions or paying the fees. Like, it just literally, you send it a signed operation and it will get it on chain, whatever it takes. It's amazing. And then we need a Mercury URL. That's the Mercury data indexer again. And we need a launch tube JWT. That's a private one. You can get your own. Just join the Passkeys channel in our Discord and ask somebody, and we will get you a JWT token so that you can try this out and experiment. I think that's all we need. What do we have? Mercury URL. Oh, we need the username and password too. Mercury email, also a private thing. Mercury password, also a super secure private thing that you don't get to see unless I accidentally show it to you. Okay, so that's our server. We've done a couple of other extra things here, just sort of to make this dApp as functional as it can. So we have a couple of stores, one for contract ID, your smart wallet contract, and a key ID, one to persist your passkey ID. And it saves it in persistent storage, local storage on your browser. And what else? I've got a bunch of like Stellar Expert things for identicons, that kind of thing. And so our routes, we've got a few API routes in this app that you don't really need to worry about at the moment. You could actually just use Tyler's Super Peach dApp for most of this, and you would be off to the races. Like if there was a service that you used that handled all of the Passkey server stuff, that this server is going to like server.send, like those kinds of things, then you would, if there was a service that abstracted this away from you having to do any of the API stuff, you could just ignore all this stuff. But we have a sort of reverse lookup happening so that you can get from our Mercury and data indexer the deployed contract ID for a given signer, a given passkey ID, if that makes sense. I also built a little fun thing to give people tokens when they actually sign up so that they actually have something to play around with and do. And this server, we're actually going to need to implement here as well, or this send endpoint. So we're going to hit API/send with a post request, and it's going to need to have our XDR. Await request.json. And then we are going to res equals await server. We're going to get that from our passkey server that we just created, this guy. So it's server.send an XDR transaction. And that's all this does. And then it returns the result. Simple as that. We get a XDR transaction and we send it along to LaunchTube, and LaunchTube handles it from there. It's like the most bonkers thing, most amazing. Okay, let's see, what are we up to next? We are going to now get to work on these actual buttons so they do more than just saying that they're logging in and signing up. So in our lib folder, we have these components, and the bulk of what we're going to be doing today is going to be in this connect buttons component. That's where the buttons are themselves. You can see we've got a button for sign up, a button for login, this button that kind of handles all of these other buttons then. And the functions right here are what we are going to implement. Right now they're just dummies so that we can get started. So the first thing we're going to do is sign up, and this is like, it's bonkers how easy, guys. First, we're going to wrap it in a try. And we're actually going to do that for login and donate if we get to that. Okay, so we're going to const wallet equals await. We get our account from the passkey client dot create wallet, and we need to pass a couple of things in, a couple of strings. They're like the app that you're building. We'll call it my guest book, I guess, and then the string that the user is going to be identified as in their like passkey, in their own passkey, sort of 1Password or Chrome or whatever. So for us, it's going to be you could do this programmatically, that they like fill out a form with their name or username or whatever. We'll just call it Arthur because they're going to be our author. Get it? See what I did there? And then we're going to get some things set in our Svelte stores. Again, this is Svelte. You can pretty well apply it to just about any front-end framework that you want. And we're going to set our key ID to be, it returns a buffer, so it can't really save that in local storage. So we're going to make it base 64 encoded, and it's going to be wallet.keyID. And then we can, here, key ID is going to be key ID. Did I not just, oh, capitals matter, guys. I don't know if you knew that. Then we're going to do the same thing with our contract ID that we receive back in our wallet. That's what it gives us. It has key ID, a buffer, a contract ID string, and XDR, which is the transaction that will need to be submitted. Wallet.contract ID. And then we'll do the same thing here. Just contract ID, contract ID. We'll check real quick if wallet.xdr exists. And if it doesn't, we'll error 500 error XDR missing, maybe. Yeah, that seems good. Commas are also really important when you're coding. I don't know if you guys knew that. Okay, then we're going to get our send function from the Passkey client. Let me pull that back up real quick. That's here. The send function is just a simple wrapper. In fact, all of these are. Send function is just a wrapper that helps us more easily submit things to our API endpoint. So we're going to send this XDR. Nope, wallet.xdr. That's it. User sign up, done. Let's check it out. I've got 1 million. Let's create a new one. Save. Sweet. This is my key ID. This is my contract address. This is my smart wallet address. So if we copy that, we don't have to, it's here. We copy that and we go to Stellar Expert on testnet network. Nope. Okay. We'll just go this way. If we click our View Wallet button, it'll take us. Oh, we haven't funded it yet. Didn't we? There might be some issues with Stellar Expert at the moment. We'll get to that in a second. I don't know if we saved it. That's probably the problem. Let's sign up again. We'll update existing this time. Okay, so our new contract ID is here. And if we view wallet, I don't know why it's doing that. We'll come back to that in a second. So this is how we have created our, let's see if we can go here. Let's try Stellar Contract Invoke Network testnet source guestbook host, what we called it. ID. That's what we need. Paste that. Okay, so we've got all of these things. It looks like it's just a Stellar Expert error at the moment. Sweet. We are deployed. We have a smart wallet in our possession. We're flying along. This is great. Okay, we're going to now log in. Just as easy. Like this is, we did account.create wallet and then submitted a transaction. That's all we did today so far. Like this stuff, that's kind of like my dApp specific. You could do it. You could do it differently. You could do something else entirely. But this is, we've asked it to create us a wallet and we sent a transaction through LaunchTube. Like that's as simple as it gets. Okay, let's do our login function. Const wallet equals await. Again, account.connect wallet. And this time, we need to give it a function. And that's, it needs to know how to get the contract ID from a given address. So we're going to say get contract ID is the aptly named get contract ID function from our Passkey client, which again is just sort of a wrapper around this other API endpoint route I had made. So that's all we need there. And just like before, in fact, we can probably just copy paste this. I love copying and pasting. We get our key ID, all of that. Sweet. Let's see if we'll add login. Login, it asks us to choose which one. I've got many to choose from. And then it tells us our key ID and our contract address. Is this working on Stellar Expert yet? No. Right now. Oh, I lost it again. Hang tight. I don't know if it, yeah, I think it's freaking out for you too. Let's see if I can. I tried this like a million times yesterday and it never did it. Let's try reload window. Sorry, this is really boring. Let's go. Yikes. Minimize. And then if we bring it back up, nope. Let's close the window. Hope it doesn't freak out our quit it altogether. Okay, file, open, recent. All right, let's see if we. Hold on a second. Yikes. Oh, crying out loud. 1 second, dudes. Okay, I think we are back in action. How's that look? Sorry, everybody. It's doing this again. Anybody know how to fix this? Yeah, this is crazy. What if we... Give me just 1 second, guys. I'm going to close the window again. It like works great, and then it doesn't as soon as I switch over to the other scene. But yes, you're right. OBS is being a pain in the butt today. Okay. And sweet. Back in action. Sorry about that, everybody. Okay. Where were we? We're using the send method, sign up, log in, right? Yeah. So we've now logged in. This needs to run again. That doesn't look good. Okay, we're going to do terminal then. Everything's going down, boys. Why is it telling me it doesn't have... Oh, npm run dev, that's why. Let's see if we can force this thing into submission. Okay, we've got login. There's our passkeys. Okay. Whew. Okay, login is done. Now we need log out, let the users get out. And this doesn't even have to be a try block. So we're gonna key id.reset. We're gonna contract id.set that to an empty string because it's not local storage. And then we're going to, for good measure, window.location .reload. Just refresh the page. Be nice, you know? So when you can see the application local storage has its filter. The key ID saved. So when we log it in, that's not what I meant to do. If we log out, that disappears. Oh man, unreal. Hang on 1 second, guys. I'm going to try and change this up a bit. All right, it looks like it. How do I put this on stage? Can you guys see the screen? Nope. My goodness. I think my problem is I didn't try this for very long. And share screen. Okay. Now, should I can't tell if you guys can see the screen or not. Looks like not. Is it because this is trying to hold on to it? Sorry, everybody. I have this really cool thing I want to share with you, but it just won't let me. Okay. Oh, man, this is frustrating. I'm going to quit OBS. Let's try running that, getting this open again to demo. Great. So far, so good. Get it running. Yeah, sorry. We will get back to it in a sec. Okay. On the plus side, I now have so far, so good. It's behaving for me, at least. That's, the most important part. Okay, let's do option, open OBS again. Okay, code, OBS code, properties, code. Okay. Okay. And if we start the virtual camera, settings, OBS. Okay. I don't know how I ended up in the corner there differently, but sorry, everybody. Bear with me. Log in and log out. All done, right? Console. Go back. Sign up. new account, and we log out, should reload our page. Good. And our application, it's empty. So we are all done with that. Now we are ready to actually make it possible to sign our guest book. Let's sign in. We've got this read page that does the that shows all the guest book entries. Right now it's just the initialization one. And what we can do is in our routes sign page, because that is just another Svelte component. You can do title, message, that kind of thing. All we have to do now is implement how to actually sign the guest book. And I've got some loading logic in here, so we're just going to start by setting is loading through. This is async again, so we're going to do another catch block. But then we're also going to and you would want to do more verbose and fine-tuned error catching in real life. But for our purposes today, this will work just fine. Okay, all we're going to do is get a built transaction from the old guestbook dot write message function. And it needs all the parameters. So author is going to be contract ID. Title is going to be our sort of bound values for these. It's another Svelte thing. Title is going to be message title. And then our text, it's going to be message text. You guessed it. You were exactly right, everybody. We get out of this a built and simulated transaction. And all we have to do is sign it. So we get our XDR string equals await account from our Passkey client again, dot sign built is going to either be there or not. And if we get to here, it'll be present. Otherwise, we'll throw an error and we'll catch it. Then we need our key ID as well. Then we await send XDR. Simple as that. So let's test this out. We are logged in, right? Yeah. So we'll sign the guest book. Dear sir or madam, we've been trying to reach you. You know how it goes. We click sign. It pops up asking us to sign with our passkey. And it's thinking, and it has been sent. We read our guest book. There is our guest book entry. You can also, like, let's invoke it from let's invoke it from the command line. Source, guestbook, host, I guess, network, testnet, read latest. And this should return us the message that we just sent. Hello, we've been trying to reach you about your car's extended warranty. So in just, what's it been, 20 minutes minus 10 minutes of farting around with OBS, we've managed to log in our user with a passkey, create a smart wallet, we've enabled login, log out, all that stuff. And we can invoke our contract address. We can invoke our guestbook contract with the smart wallet. And the user never has to even know what a wallet is. They barely even have to know that they're using a blockchain wallet to begin with. This is truly like as easy as it could be. Tyler's done an amazing job of getting things up and running and ready. Okay, let me check on the chat real quick. Yes, it is an elliptical. It is broken and doesn't work, but I haven't fixed it yet. Okay, glad you guys are with me. Let's see if we've got some more time and if things manage to go in our favor. Our funding thing works. Let's add that to our sign up. We await the send then, and then when it's done, we can fund. It's just a function I already wrote that, again, piggybacks off of the fund API route that I already have. So now when we sign up, we should get a balance of 25 lumens. Let's try that again. Let's log out, sign up, and we'll save a new passkey. We get our contract ID, our key ID. I think it will tell us when it's funded. Yes. Funding, funded. Amazing. Let's see if Stellar Expert's working. Still nope. Sorry, everybody. Stellar Expert's having a testnet issue. But if we check contract invoke ID, what's the native? Stellar contract asset ID, asset native. So this is the one we're going to invoke. Stellar contract invoke ID. This one, source, sure, Alice. Not transfer. I want balance. ID equals our passkey wallet. And it should have 25 lumens to our name. Yep, there we go. So we've funded our account. And let's see if we can, real quick, we've got about 10 minutes. Let's make this donate function so that we can actually do something neat besides just signing messages and stuff. So we will, again, in a try block, we'll get an amount and we'll just do a prompt. How much to donate? And we can suggest maybe users want to donate 10 lumens, who knows? And then we'll get another built transaction equals the native asset client, which again, we've just exported from here. The Passkey kit comes with some like re-exported SDK stuff, which is really, really useful. So we're going to do native.transfer. We're going to do from our contract ID to, and this is where we're going to use the generated bindings, have a native dot, nope, not native, networks dot testnet dot contract ID object, and amount is going to be, we need to make it a big int number amount. We have to times 10 million because it's stroops as opposed to lumens. And then we get an assigned XDR from our account.sign built key ID, and then we await send XDR. Is this? Oh, you need to await this. And then we've donated the amount. I think we need to await this too. All right. So now, log back in. We're already logged in. I don't know why I keep doing that. I'm not solving the puzzle. I wish I could. Then we will send a donation. How much we want to send? We'll say 5. Okay. And it's asking us to sign. We could just easily do all this with our YubiKey, or whatever the case may be. And we have donated $5 whole. Let's see if Stellar Expert is still having some issues with testnet, but we can see that our contract is our contract address's native balance should now be, what did we do, 5 lumens? Yeah, 5 lumens. Okay, so friends, that's about all I've got for the demo part. I know we had a lot of trouble, a lot of struggles, but in just a few minutes, we've been able to get a user a smart wallet, get them on chain, signing transactions, submitting transactions, and it even allows us to do, like, they can use this account for anything. And it's just amazing the work that has been done to make this happen, the work that's been done to make this seamless and as easy as possible. Is just fantastic. That is going to do it for me. I've got some more resources here. Let's see the questions, if we've got anything. Sorry, the quality kind of suffered probably after several of the OBS crashes. I do think we're recording it, so hopefully that'll work. Can they use the same account for other things? Yeah, you have the ability to, right now, there's not like a lot of ergonomics figured out behind like how to display these kind of interfaces to the user from like one dApp to another. But the authentication will work for any contract invocation. If I could do it in the terminal, I'd show you that. I don't know how. Maybe it's possible. Maybe somebody else knows how to use Passkeys in the terminal. But this same smart wallet, same contract can be used to authenticate just about any Sorbonne transaction, as far as I'm aware. I think the CLI also is having some check off things that don't quite work right yet. So maybe that's another barrier. Any other questions in the chat? If not, I will call it adieu. This is actually, I almost forgot, the demo is a more functional and more polished version is available on Vercel. There's a link there. If you scan this QR code, it'll take you to the source code repo that has all these links you can click on as well. You can log in just like normal, do all the, this might actually be indexed by Stellar Expert at the moment. You can do any donation, any smart contract invocation. Imagine if you wanted to integrate more contracts as a dApp developer, you'd have to do this like sort of contract by contract in the dApp, at least at the moment. That's kind of what's going through my mind. But there are people far smarter than me who are going to make this even more useful, even more amazing over the weeks and months to come. So stay tuned. It's going to be awesome. Thank you all so much for joining me, and have a wonderful afternoon, morning, evening, whatever it is, wherever you are. Thank you and have a great day.